Hello, I'm just gonna start the explanation video of lifeguard problem here. This is the problem description. If you need to, you can pause and briefly go over the description from now. In this problem, we have to find the maximum length of coverage time based on the lifeguard's schedule. Each lifeguard's schedule have start time and end time. These schedule could be overlapped. Let's go over important points of this problem. First, the time frame, aka opening time for the pool, is between 0 and 1000. Also, we want to check the scheduling format. If lifeguard A has schedule from 1 to 4, then it covers 1 to 3, 3 units in total. Checking input and output format is also important. The first line of input represents the number of lifeguards, and each line of the rest of the input shows the start and end time for each lifeguard. The output is the maximum length of the coverage without one lifeguard. Now we are going to explore the example and solve it manually. There are 3 lifeguards in this example, and then I'm drawing the line segment in this graph. It is also important to build intuition of how to solve the problem manually, which helps us to formulate the solution later. Here we use the example of 3 lifeguards, and green lines gives the maximum coverage of the schedule. Can you explain the logic of how to solve this problem? Now we can formulate the strategy. You can pause if you need, but if we can approximate there are 4 steps to solve this problem. Let's think about how to solve the main part, which is finding the maximum coverage without one lifeguard. One thing we can focus on is the size of the solution space. The number of lifeguards is between 1 and 100, and also time frame is less than equal to 1000. In this kind of small solution space, we can always try brute force method. The brute force approach explores all possible solutions. In our context, we skip one lifeguard schedule at a time and compare the coverage of every cases. The advantage of this approach is the correctness of the solution, but be careful about out-of-memory error. This is the steps of brute force approach implementation. You can pause if you need. Note that it takes O n square for the second step, as we need to iterate over the lifeguard schedule for every single case of a lifeguard removal. Now let's look at the actual implementation. In step 1, we load the data into array for the father process. I wrote the custom method for readability, but let's pretend that we store the start and end time in distinct arrays for each lifeguard. In step 2, we're gonna use brute force approach by skipping one lifeguard at a time and calculate the coverage for the rest of lifeguards. In step 3, we update the maximum coverage for each iteration at the end of the loop and store the value for the next iteration coming up. And finally, in step 4, we print out the maximum coverage in the end of the function. There are several things I want to discuss. First of all, to calculate the total coverage without one lifeguard, we need to come up with some ideas to track the coverage for each lifeguard. One of the approach to solve this is that creating another array to update the coverage over time frame. As the time frame space is not large, we can initialize an array which has the length of 1000 and 0 as an element. Each index represents the time frame. Every time we iterate the lifeguard schedule, we're gonna increment the value by 1 based on the schedule time frame so that we can track the total schedule coverage. In this way, we don't need to worry about the overlap of the schedule because at the end of the day, we only have to count the number of non-zero integer in this array, which corresponds to the total length of the coverage. We also want to explore the details of brute force. First for loop is tracking which lifeguard we skip. The second for loop is for iterating over all arrays to sum up the coverage. To differentiate skipping lifeguard from the others, we can check the index number of the array. If it is not a skipping lifeguard, then we can process further. For updating the schedule array, I also wrote a custom method for readability, but after all, this is for incrementing the value between the start and end time of the designated lifeguard schedule we are iterating over. At the end of the first for loop, we're going to calculate the total coverage without one lifeguard by counting up the number of non-zero integer in the schedule array and compare the previous maximum length to update the result. At the end, we also need to reset the schedule array as new iteration for new solution case will start from the next line. Now we can dive into implementation details of each custom function. Use file input function is for loading the schedule for each lifeguard and store them in two-dimensional array. We just call Java's file class to load the file path and scanner class to read the content. The first content we expect is number of lifeguards, so it is better to store in a static variable for later use. For the rest of the lines, we just store start and end time into each array, which is in a bigger array, as it is two-dimensional. Update schedule method takes three parameters: schedule array to update, start time, and end time. What we do is simple. We just increment the values between start and end time in schedule array and return. Calculate max coverage method is also fairly simple as it only counts up non-zero integers in the schedule array and return the number of them as a result. This is the end of brute force approach explanation. Next, we can explore a little bit better solution. The idea is that what if we can track the non-overlapping area for each line segment representing each schedule? Then the line segment that has least amount of non-overlapping area has the least contribution to the schedule after all. But how can we formulate the solution because it sounds too many things to track? One trick we can use is that dividing the line segments into smaller parts so that we can track the number of lifeguards on duty and the length of the coverage at the same time. If we divide them based on start time and end time of each schedule, we can somehow find the non-overlapping area for each schedule. In this example, the first and last line segment has 2 units of individual contribution, and the middle one has 1 unit. Therefore, the middle lifeguard schedule should be eliminated as it has the least amount of contribution, aka non-overlapping line length. It turned out this approach or similar approach is categorized as line sweep algorithm. In this recipe, we have 5 steps to follow. You can pause if you need, but as you can see, we create a new data type called event, which stores start and end time separately and sort them out. By doing so, we can track the events in order, which helps us to track the number of lifeguard on duty. Since sorting takes O and log n, it seems a little bit better approach than the brute force approach we explored in the previous section. In this example, each blue line segment represents the length between events. By separating the scheduling interval into start time and end time, we can track these segments separately efficiently. Also, by adding +1 or -1, we can annotate the data as arrival and leave from the duty. By sorting each event, we can track the on-duty lifeguard by counting the additional information we talked about in the previous slide. It also helps us to calculate the length of 2 events as it is in order. After creating event objects and sort them out, we can iterate these in order events. We can calculate the length between 2 events and track the number of overlap. If it is non-overlapping, then we can store the length as an individual contribution to schedule. To find max coverage, we need to calculate the union length of coverage. As each blue line segment is an independent length of 2 events, we just need to sum up each range of 2 events. As you can see, we already know the non-overlapping length for each line segment, so we just need to subtract this value from the union length. The maximum value from this operation should be the answer. Finally, we can go over the implementation details. First part is mostly the same, but we need to create an array list to track the events and also initialize events based on the input. You can combine this part with this custom method as well. And next step, we're gonna sort these events based on collections class, which is built in Java class. Next chunk of code is just for the sake of variable declarations. The first things first, we need to have some kind of variables that tracks the event's ID, which basically represents which schedule this event belongs to. By doing so, we can tell if the current iteration is overlapping or not. The rest of the variables are for storing the union length and the array to store the non-overlapping area. But we also need to have a variable that stores the time of the previous event. so that we can calculate the length of this event range easily. In the next part, we are going to iterate over this in-order list of events and calculate the length between them. If active set size is more than 1, then it means these events are overlapping. If the size is just 1, then this length is individual contribution of one of the events. It is easy to track which event this non-overlapping part belongs to because active set gives us the event's ID, which basically tells us which line segment we are currently tracking on. In the end of event iteration, we want to update the active set based on +1 or -1. Each event has arriving or leaving representation like this helps us to find if we are still on the current event in the next iteration. Also, don't forget to update the previous time for the next iteration. As we discussed, now we can calculate the max value for schedule coverage based on the non-overlapping part for each line segment. In the last, I want to cover how the event class is implemented. It is straightforward as we just declare a class variable for each information we want to store, which is time, and then +1 or -1, and also the schedule ID. And this is the end of this video. Thank you.